Okay, we are live, and that is out into the Twitter universe. So, Facebook is called Meta. I don't know enough about that world to comment on that. So, there's too many things going on the internet. You can only pick a few things to get really involved in. There we go. My thing that I'm really involved in at the moment is building Nutrify. In other words, take a photo of food and learn about it. Let's pop out the chat. Shivans, what's going on, my friend? It's Friday, team. Who's ready to have a big party? Yesterday we got... I'm going to minimize that. I've now... Look at this. I've organized my camera to not have the screens in it. So we've got a new point of view. Hello, everyone. Let's jump into here. So we've started downloading some images from Bing that actually worked. Can you believe that? Nutrify... 10 Whole Foods. Look at this. We have nearly 1,000 images. So we have 100 images per class. So what we're going to do is we're going to clean out this data set. Silsum, hello. Sally, hello. But there's some images here that are broken. You see these ones? Broken. Broken. Now let's have a look at this banana. Samanth, I'm uploading it to the archive channel now. Samanth, sorry, Shivans, I didn't actually know Fast AI had this. I kind of copied this from a Pi image search tutorial, as well as just Microsoft's guide on how to use their image API. It's actually pretty straightforward, but this is the code that we have in the data download notebook. Essentially what it does is just a quick overview. We have a subscription key to Microsoft Azure. We have a Bing Microsoft. Oh, there is a way to verify if the images are not broken. I am Vazu, hello. And then we write some code here to download images. And then we download the images there. So yeah, if you want the code, it's the data download notebook, but it's pretty messy at the moment. I'm going to convert it into a script probably early next week. The way I'm going to do this, Shivans, I figured out for me, is I'm going to batch download the images, which we got there, and then I'm just going to run a function over the images that we do download, and if they can't be opened, we're going to delete them here. So this is where we're up to. Scan through the downloaded images, and if they don't work, delete them. So we can get all of the path names that we're working with. So let's just start up here what we're going to do. 29. Got this. So we can tick that off. Tick. We've got about 100 images for each class. We've got a table that says the metadata. Now we want to, we're going to clean up images that are broken from file structure. Broken image 1.png. This image is broken. Samanth, I don't know how to... Samanth asks, how do I plan to retrain the model? Let's say after a few months when you get feedback, new data. What's the pipeline like? I have no idea. We're going to build that. We're going to build that as we go, you know? I've got to figure this out. I've never actually done that, so we'll see how best to do it. Clean up metadata. This is the three things that we want to do today. Metadata table, and remove images that are broken, image IDs that are broken. Yeah, I don't know what the full pipeline looks like. We're just building one little piece at a time. We can't think about this thing, the pipeline ahead of time, if you know what I mean. We have to build a little piece, figure it out, build a little piece, figure it out, and then just iterate over time. And then we also want to build a small machine learning model to fit the data. Okay, so this is the 3 things that we're going to be doing today. It is the 29th of October 2021. I'm going to turn that into Siobhan's. Remember that what are the chances for my school project and those clips that we have on my Twitch that you clipped for me? Thank you for that, by the way. I'm going to turn that into a small YouTube video, and it'll be like 2 minutes long, and it's like what happens when someone's doing the same project as you. Okay, so let's get out of this. Let's now figure out how to delete so pathlib.path. Let's just see if this works. Hey Radak, how are you? I don't use the Pomodoro technique while I stream, no. So Pomodoro is good for when you're getting started. You just have to figure out how to learn how to concentrate, because a lot of people's like concentration is just broken. But once you get enough practice, you can just sort of work for however long you need to work for, and then take a break when you need to take a break. But Pomodoro is good to sort of just get in the habit of being in concentration for a long period of time. So I've built that habit of being able to concentrate for a number of hours. So when I'm streaming, I just stream until I get bored. It's actually magic how they do it in Fast AI. So you're better off doing it yourself. What do you mean by it's magic? As in the code is behind the scenes? Oh, download images. Okay, yeah, that's not too bad. That's similar to what we're doing. Yeah, that's very similar to what we're doing. They have a key here, and yeah, images on Bing, and then they get the results. That's very similar to what we're doing. Oh, okay, well, let's just re-implement this sort of from scratch, and then we'll create a script like download images. So right now, let's see what we've got. We've got this metadata table, which is here. All right, this is our target images. So right now, we tried to download all of them. There's about 1,000 of them. We can clean all this up, but this works. And right now we've got images that are here. However, some of them are broken. So now we need to go through each of these and delete the ones that aren't good. And then we can remove the image IDs that don't exist from this table, export that table. So this script is going to end up being insert search terms. So you can go download images and then a list of search terms like this. And then it will download images from Bing from the search terms, and then it will export a CSV of the images that were downloaded so we can use this later on, and then it will clean up the directories with the broken images. It will download these images here, so there we go, and then it will go through. We're about to write the code that will delete the images that don't work, and then finally it will update metadata to reflect deleted images. So that way, by the end of it, you've got folders of images plus a table of metadata of what you've downloaded. Now, I will have to implement later on in the database a way to detect duplicates. That will be fun to implement. So root folder is going to be 10 foods test, and let's see. So we've got a DS store there. Classic, Apple. Okay, so here's all of the folders there. So what we want to do is, now they say on Stack Overflow that apparently you can also use path lib. What does this do? Print. Is path lib automatically imported? Path name. Do I have to import path lib? Okay, so these are paths now. Yo, Hasmanator, how are you? Hamzanator? Oh, wow. Radak, where are you using that duplicate image check? If you want to upload images, you can go to Nutrify.app. Look at this. The website is live. This is how we do it, people. Nutrify.app. Take a photo of food and learn about it. I need to post this to Twitter, actually. Upload an image of food. That's what we should do by the end of the stream. There. This will be a fun tweet. The homepage for my new, let's put that out there. Let's put this in number 3. Is that update Nutrify homepage so it's ready to share. E.g., what does Nutrify do? Wonderful. Okay, we need to remove DS store. Let's go here. How's the camera settings, by the way? Is everything visible? RM. There we go. So, okay, so path lib creates a path. So, image files to check. Let's create a list. Image files to check dot print name. So that's the key. That's the image ID key. So we can go name dot split and then get 0. There we go. Okay. Image files to check, and then we got that. Okay, and now for image file path in image files to check. Print image file path. Okay, so this is our image file paths. That's fine. So we get the paths here. Now we want to try to open each of these, and for the ones that can't open, look at this. So here, we don't want to just run this yet, so I'm going to make this error on purpose. Try. How did you choose whether to use SQL-based Postgres or NoSQL? So I don't know enough about NoSQL, MongoDB. So Postgres was just that, whatchamacallit. Postgres was because the data I was creating was structured, and the databases that I was working with were relational. So I chose Postgres. Siobhan's asked, Dan, is your place next to the sea? Yes, it is. You want to see? You ready? Look at this. Let's see if you can see it. Hey! There's the ocean. Can you see the water? That's the water right there. Just out there. There's the ocean. Beautiful, isn't it? It's beautiful to fall asleep to, you're right. Now, let's get me back on this camera. Hello. Hello, can you see me? Yes, you can. Okay. Is that good? How crazy is this that we can just be wherever we are in the world and then just transmute this across the ocean? So yeah, the ocean is just there. It's about 50 meters. I can walk to it in about 2 or 3 minutes. So let me just come back here. There. You're also getting the camera metadata. Yeah. So let's now Silsum's asking, how do we do this? You mean this? How do I get them in these folders? So when I download them here, I create a folder of where to save it. So save path. Save path creates a path to save it in the class directory. And the class directory is the target directory and the search term. The target directory is this, 10 Whole Foods test, and the search term is one of these values here. So it creates a path based on the specific class of image that we're looking for. All this code's on GitHub, by the way. If you go into here, so now let's delete an image. So let's just see what happens when it tries to open. Hey. I need an accept. Accept. Oh. There we go. So we have some images that are broken. Now we want to print Ashik, what's going on? Do I have any mates into ML coding AI? Yeah, one of my good friends, Michael, is into it. If you're talking about like people I interact with in real life, my little brother is coding iOS apps. He's actually building the iOS version of Nutrify. So stay tuned for that. I just got to get him a model. I should get him a model by the end of today or tomorrow maybe. Image file path. Let's go. We want... how do I get the last part of a path? Image file path. Python split file path to string. Is that going to work? Yeah. Path equals os path dot split. Or should I do, can I just do path lib split? Is that a thing? Maybe not. Or maybe I should do image file path. Is it -1? Let's try this. Let's play around with the file paths and just code it. If in doubt, code it out, you know? 0. What does this give us? It gives us a path. What happens if we take, can you index on a path? -1, okay. What does a POSIX path give us? POSIX path. Real Python path lib. Here we go. Taming the file system. How do we interact with the POSIX path? POSIX path. Oh, stem. Oh, holla at your boy, baby. Look at that. We can get the stem. That's very cool. Okay, path lib. Oh, don't want that. Want this. I'm going to read through that later on. Let's save this to Python. And then we want... see here for more on path lib. So .stem gets the file name from a POSIX path. Path data type. So that's where we can come down to here. We're slowly building up image file path, and then we can just go .stem, and then we can go print f image ID is broken because oh, team, look at that. Friends, we are coding geniuses. This is how you really learn how to do things, is just by exploring and trying different things and working out, you know what, I need this for this. So now we want to check each image. We want to store the image ID that's broken so that we can later on remove this from image. What's our dictionary? I mean our data frame called. Want to remove it from the metadata. Tag image df. So tag image df.head. So we need to create another list of broken images. Broken images equals an empty list. And then we go broken images dot append image ID. Print deleting image. Total images removed, len, broken images. Boom. Now, before we make this, let's just make a copy of this. Who's ready to see this in action? So my theory is that the smallest images should be deleted. Are we going to witness these being deleted? Let's have a look. So for image file path and image file paths to check, try to open it. If it doesn't open, I'm going to put this here, actually, get the image ID. Get image ID. Broken images dot append remove image file path. Who's ready to go? 3, 2, 1. Should we see these images over here deleted? Oh, gone. Total images removed, 166. Wow, that actually worked far better than what I thought it would. We have no broken images. Okay, that worked really well. And now we have broken images. And then let's get, so this is going to be a list of all the images that are broken. What we can do is we can verify this by making sure team, we're actually doing this. We're actually building a data set that we can use from scratch. So now remove broken images from tag image df. So tag image df good equals tag image df, and now tag image df every image ID that's not in broken images. Not in the truth value of a series that string dot contains Siobhan, you just wait, my friend. We're going to have the data flywheel. I reckon if we get 2 more months of streaming and coding, we'll have a data flywheel in place. Like, take an image, take a photo, it doesn't work, it'll go back into a database, we'll download better data and keep going. Best time as an Apple genius. Oh, we'll have to save that for another time. I want to finish this code. After I finish this code, we'll celebrate that. If we finish all this code, we'll celebrate with a story. Remind me. I want to do at least these 3 before we do story time. So there's a better way to do this. Not contains. Tag image df. Can we do, is there not? How do you do pandas not again? Is it a squiggly symbol like this? Pandas filter column with values not in a list. It's that squiggly line, isn't it? Not in. There we go. That's what I wanted. Tag image df is in. We want look at the target tag image df and filter for images not in the broken images. And then we can write some code to verify it and whatnot. Let's vote this up. Dot is in broken. There we go. And this, yeah, there we go. 834 rows. That makes sense. Tinny TV, welcome to the stream. Okay, look at this. Tinny, I'm going to get you a model over to you soon, all right? Dot head, and now let's get the length of tag image df good. Okay, 834. I'm going to get you a model today, all right? A model today. Core ML model with the classes. But look at all this code we just had to write to download images from the internet. Look at this data set, Tinny. We've got 100 images of apples downloaded, ready to go. And then, of course, we can add more of our own data later on. We'll have to delete that crappy image, but we can filter out images later. And then honey. Honey will be the interesting one. We can filter out the crappy images from this later. Honey will be the hard one. But we are good. Let's verify that images in saved folder are in metadata CSV. Could I upload all of these to GitHub? Is that too much to upload to GitHub? Probably. Nutrify, 10 Whole Foods. How much is this? 110 megabytes. Yeah. Are in metadata CSV. Oops. So we want get list of saved images and then make sure that they're the same. How did we do that before? Saved images. Apple will just be one of a kind at the start. Saved images, but we don't want the full path. We just want stem. Saved images. Saved image IDs. Let's call it that. That's a better. Friends, we're going to be building a model today. DS store, the classic DS store is there. I want to remove the DS store. Remove. There we go. And now we want to assert saved image IDs equals tag image df good dot image ID dot to list. Assertion error. What error did we get? Are they in the different order? Okay, maybe we want sorted. Let's sort them both. Assertion error. Oh no, what's happening here, my friend? How do you get the intersection of let's go set Python, see where sets are different. What's that called? Difference. Dot difference set They have no difference. What's the deal here? False. There's no difference. You lied to me. Unless there's a double up. Sorted. Oh, okay. There's a double up. Maybe in the tag image DF good list. It didn't get all of them. Okay. But there's no difference here. Let's get... How many broken images do we find? We removed 166 out of 1,000, so that should give us 834. Then why is saved images only 118? We're missing some folders here, team. Reverse them, Samantha. I'll give that a try. Is that what you mean? Difference of the tag image. Ah, we find some missing images. Now, where are these? Let's go. False. So the saved image IDs, we've got something going on here. $818. Ah, you know what? I think the ones that aren't in here don't exist either. Like that image, so this is scanning the images that are actually there. This data table, I've got an idea. We can go copy. There we go. There's the difference. So 16 images couldn't be downloaded to begin with because they would have timed out. So this is some broken code in our functionality. Here, if we have a timeout of 30, if the URL doesn't download in 30, it doesn't get saved either. So we should put a list here of what doesn't get saved. We can fix this by doing finally, I believe. Python try except. I like real Python. I need to create a GitHub account. Try except. I think I can do a finally here. Try run this code. Yeah, that's what we should do. Else. Using else statement, you can instruct Python program. Only in the absence of exceptions. Yeah, that's what we want. There we go. Yeah, so there would have been some images here. Yeah, so chicken wings got broken. Egg got broken. Okay, so we're saving, before we were saving all of the images regardless to try, get the image, write the image to file. If the image doesn't download, skip it. It will only run if no exceptions. That's what we want. Only run if there's no exceptions. Yes, that makes sense. We want to skip the images that have exceptions. Beautiful, updated that. So now we can update the metadata with what we actually have. So this is the ground truth here. So if the image ID, let's remove we'll remove the metadata here. These are the only images that we actually have. So let's see what the length is. I'm going to clean all this up and put it into a script, by the way. Beautiful. So now we've got, so this should work. True. There we go. Assert. We now have a way, friends, to verify. Now let's export. Export the metadata CSV for later use. What can we call it? We need a data folder here, don't we? To CSV. We'll clean up the repo. I'll clean up the repo over the weekend. To CSV, and do we have this? Wonderful. Look at this, team. All of our images. These are the only images that we have. $819 images. On my deep learning machine downstairs. Actually, that's where I'm running this PyTorch code. So I'm building a PyTorch course, and it's all running on my deep learning machine right now. So if you see down here, SSH, that's the local IP address for my deep learning PC downstairs. And this is Food Vision running on the Mac right now. But when I'm going to train the model, it's going to be on the deep learning PC. I actually just emailed NVIDIA today and said, hey, I'm going to be working on a huge machine learning project next for most of next year. Do you want to give me some hardware? So we'll see where that comes from. So look at this, team. We now have a data set. We have a full-blown script that can download images from the internet and verify them and store their metadata. So now, what's the time? It's time to train a machine learning model. Remove image IDs that are broken. Let's build a machine learning model. So later, clean up, data download script. I literally just emailed NVIDIA today So I don't know. They have a NVIDIA event in the GTC, and I'm going to be live streaming that on my channel, going through it, watching it. So they might announce some new GPUs or something like that. I actually don't know what they're going to announce. But I said, hey, do you want to? I'll say that I'm using NVIDIA stuff, and that's the way this like world works. It's like a sponsorship deal. It's like, I'll use your cards, which I'm going to use anyway. Do you want to have however many people are watching my videos know that I'm using your cards to train my models? Clean up data download script, so you can pass. Please add end-to-end project like this one in the PyTorch course. Samanth, stay tuned. The PyTorch course is going to focus strictly on PyTorch. I'll probably the end-to-end project. I'll be making videos on this properly on my YouTube shortly. I want to get the first prototype of stage 2 live before I start turning this into YouTube videos. So you can pass target classes to the script, e.g. Let's say, what other foods haven't we got? We've got a lot. Let's say milk. What's another food? Avocado, pear, and it automatically downloads images for those foods, plus saves metadata. Okay, let's build a machine learning model. How about we do that? Do I have TensorFlow in this environment? I don't think so. No module named TensorFlow. Do I have PyTorch? No name Torch. Do I have CreateML? Let's see how CreateML goes. CreateML. Nutrify. Let's go Nutrify. New project. Image classification. Food Vision V0. This is the first version of Food Vision. What's created in here? Training data. Do I need to split this into train and test? Hey, why didn't this work? Oh. Select. Let's do a whole bunch of augmentations. And let's train. Look at this. Just training a machine learning model straight from Food Vision V0. In the meantime, we'll start to build a TensorFlow model. I need to set up an environment here. Let's put this over here. This is on my Intel machine. with an Intel Radeon Pro, 8 gigabytes graphics card. Mind you, I'm streaming as well and recording, so the model probably won't train as fast as it probably could. But this is going to be similar to what we do for... I've got a couple of new Macs on the way. I'm going to test those with the new chips and compare them all. But we need to get TensorFlow. 64 gigabytes of RAM. Let's just keep that over there. And we need TensorFlow. So where's this environment being built? Do I have a Nutrify environment? Hey, we are running in Nutrify. Let's go file, new file. IPyNB. Hey, what happened to my notebook? Rename. Model building. We're going to clean up the repo, don't worry. Select kernel. We want Nutrify. Do I have... I don't think I have TensorFlow in Nutrify. Import TensorFlow as TF. I'm going to need to install TensorFlow. Paran Joy, can I recommend good resources to learn NLP? I'd go to the Hugging Face course. Hugging Face is probably the best place you can go there. So, how about I build this on... Google Colab. And I'll install TensorFlow on another stream when I have time to set up environments. So let's get Colab open. Oh, my computer's going quite slow. Hey, little math boy, what's going on? How am I building my data set? I've got a script here. Well, a notebook. I'm going to turn it into a script. It's data download.ipynb, which I just finished it actually. It's on GitHub. Alessandro, I've got enough pages open, my friend. We can get rid of all these, actually. You happy now? My computer is training a model, that's why it's going so slow. So I built it off this article on how to download Little Math Boy, this is for you. How to quickly build an image data set. I copied like a fair chunk of that, but also the Microsoft guide is pretty straightforward too. So this one here. But what this notebook does is, and again, I'm going to clean it up and turn it into a script eventually. But this is a more modern version of the two things I just linked, this notebook, which is on Nutrify data download. It may be moved at some point, so again, I'm going to tidy up the repo at some point. I'm saying at some point a lot, but you've got here, you set up your Microsoft Bing image search key, which is an API. You sign up for Microsoft Azure, it's free until you go over a certain limit. The cost, even if you do go over that limit, isn't too high unless you're downloading like hundreds of thousands of images, which I'm not. I might eventually do. You have the search URL, then you create the request that you're going to send to that API, which is a Microsoft API, using a bunch of parameters. The parameter lists are on Microsoft's documentation for that API. Then you get back a whole bunch of results that look like a big Python dictionary, which is JSON. And inside here are the image URLs to the images from Bing. And I've put a little thing up in here that the license I want is public, so the images are going to be public only. So I don't want anything else that's not public. Don't want to run into licensing issues later on. And the image type of photos, so I don't want drawings or clip arts and whatnot. I just want photos of food. And then we go down here. I've written a whole bunch of custom code to download these 10 classes that I want. So these are the search terms. You can create your own search terms. I set up the API, I set up the URL, number of images. You can upgrade that. So the maximum is 150 at a time, but you can work that out to be actually more if you write something to deal with different pages. I haven't figured that out yet. I'm going to do that later on. This code here creates a list of dictionaries of different images to download. And so we get back adding URL image for this, yada, yada, yada. And then we finally I ended up with a list of dictionaries such as image ID, which is just a unique identifier. Where's it from? What's the search term? What's the image URL? Height, width, time downloaded, etc. And then I put this into a data frame so I can export this to CSV so that I have a metadata save of all the images I've ever downloaded. That way later on, when I'm going back through my data sets, I can figure out, hey, where did this image come from? When was it downloaded? Etc, etc. That'll be in use later. And then finally, so once I've got that image to download list, I then write some code here to download the images using requests. Again, I write the image to file. A better way to do this would be to, if the image doesn't download, so if the timeout passes 30 seconds, it's going to have an exception. And then it also saves metadata to the metadata table. We go down here. That's what I actually need to fix. If the image gets saved, okay, I think this is wrong. This is wrong. That's good to go back through the code. That should be up there. So the metadata gets created. So that's what I got to keep in mind for a long time. And then I go back through and check here, delete the images that don't work because some of them are broken. And then I verify to make sure that the metadata reflects the actual images that are downloaded. A lot of stuff going on there, but that'll be on GitHub. Let's just upload this. So you'll need your own Microsoft Azure key to use that. Again, the code is not tidy. I'm going to put it into a script that makes it look nice and tidy. Commit update data, download notebook to remove bogus images and verify metadata. So this should be just updated now. Hey. There we go. So data download.ipy notebook. Kendall Percy Money says, what would you say is the best way to get into machine learning? No other better way than to just start. Follow your interest, man. There's no like set path. You can read about how I did it here. www.mrdberg.com/AIML. But really, my advice is just to start coding. Start writing ML code. You might be more interested in the math. Personally, I'm more interested in the code because a lot of machine learning, look at this. Before we even wrote a single model, I was downloading data. And Lil Math Boy, you're right. I'm going to start with just 1,000 images to begin with. Why? Because I want to make sure everything works before I scale up. Like, scaling up is the fun part. You need to make sure that the system works overall before you just start throwing more data at it. So what I'm doing with this data flywheel, if we go back to Notion, hey, our model's training, look at that. Wow. We get 98% accuracy. So here's what we're doing. We're building a data flywheel. We're copying Tesla's system. Right, because Tesla have worked this out. They've worked out how to make this big data engine, but I want to build that for food images. So we're doing small pieces of the puzzle at a time. So we need a way to take images of food. I know that the models are going to be good because the models that are out there are really good. What I care about is the data. The data is the key thing. If we have a way to get more data, we have a way to make better models. The models are already really good, like EfficientNet. I'm about to build an EfficientNet using TensorFlow, and it's going to take all of 10 minutes. So the data is the key point here. And you start with small amount of data so that we can run heaps of experiments, and then we can start to scale up as we go. I've got 1,000 images right now, but I've got a folder of 800,000 images ready to go. They don't have labels, but these are labeled. I need to create a whatchamacallit. Oh, look at this. This is Create ML. This is working really nice. We have 74 images of apple, 74 of strawberries, 77 of mushrooms, beef, chicken wings, carrots, honey, egg, etc. But if you want to start ML, look up my article. Daniel Burke, 5, or watch my ML roadmap. Beginner friendly steps to start ML. There we go. Read this. Ollie Oxenfree. You become a much more powerful data science when you're a skilled software developer. Yeah. So I am not a software developer. I am a hacker. I am slowly becoming a software developer. A hacker means that I can kind of just piece things together. Right? But the first iteration of this is going to be just pieced together. Me just hacking around, not really know what I'm doing, but just putting the data where it should go. And then as it gets better over time, I will either hire someone smarter than me to turn it into a full-blown software developer, software engineered project, or I will learn how to do it myself. But to begin with, it's going to be a hack together, somehow works system. I'm going to use Google Sheets as our database. Matt Welch says, are the labels based on Bing image classifying them properly? So that's something we could verify, but it looks like the model is doing pretty well anyway, even with them. Like, look at this, iterations. Converged early at 10 iterations. So we got training accuracy of 97%. We don't actually have a test data set. So what we might do is create a test data set now. Let's see. Look, Bing is just full of junk. Images, Apple. This is what we've done. Oh. We've said to Bing, hey, only give us, look at this. If we just search for Apple, we get all of these photos of Apple, the company, Apple Watch, right? But if we refine these, we can go photograph only. Look at that. Much better. And then we can also go license is public domain. Beautiful. Look at that. Yeah, we need to make a test data set. Let's do that. And then we'll train a model with TensorFlow in a second. And we'll see how close our TensorFlow model gets to create ML. But that's pretty darn good. Validation accuracy is actually higher than training accuracy. But let's create a new model. But this is a beautiful of the Bing search API. And then we can go banana. Look, that data is pretty good. The issue would probably be more that there are probably more than one possible foods in one photo. Yeah, you're right. But we'll work that out later. We're starting small. Again, starting small. Start with a single image classification problem. Banana, and we also got honey will be a hard one. Look at the different types of honey there are. If you search for honey, you get images of bees, which is not necessarily honey the food. Apparently, Alessandro says there's a Google Chrome extension for doing Google images as well. If you have the link to that Chrome extension, please send it through. I'll check it out. Let's make a training set, test set, sorry. Where can we do this? Model building. Let's go. We'll rename this to train test. I'll make another file in here and clean up the repo in a second. Train test split. So yes, this is very hacky. ls, we want 10 whole foods. Is that what it's called? I can't even remember what my data set is called. Data set. 10 whole foods test. Yes, Python. ls, now we can get all of the file names. Okay. Make train and test sets. We want to split the files in a target folder into train and test sets. We can do this randomly. Let's just do that. We'll make 80-20 split. Download all images. Beautiful. Thank you, Alessandro. Let's split the data into train and test sets. So we need all the file paths, and then we can go, let's go this, target equals test. Then what was the code we used to get all of the subdirectories? There we go. So let's see what's in there. Go for a walk in the target dir. And then we want file paths. File paths. Wonderful. How many do we have? It's like 800 or so images, right? So now we want to just randomly select something. How do you shuffle a list? Random seed. No. Import random. Train IDXs. Train index equals random dot random integer in range. How do I get in Python? Nano Aquila, hey, what type of learning process are you using? I'm not sure what you mean by learning process. Do you mean machine learning algorithm? Permutation? Random.perm Python. What does this do? Shuffle an array. Oh, supervised. Supervised learning. I have data and labels. So how can we do this? We want to create just a random. This should be quite easy, but I'm making it hard. We want to just create a random list of indexes from a range of 0 to I got an idea. Indexes. Indexes equals range lang file paths, and then random indexes equals random.shuffle. Can I do seed? There we go. Oh, it's NumPy random. Okay, that's what we can do. NumPy. NumPy has no shuffle. Why didn't that return anything? Does it return a copy? What? Does it do it in place? 86. Okay, it does it in place. I didn't know that. There we go. Okay. So now the train IDX train split equals 0.8 round int 0.8. We can index on this. How do you unlist a list? Unless we turn file paths into an array. There we go. We've got test and train. Okay, now let's move so OS. Can this be a list? What should we call the data? Do I have images here? Okay, so this is busted. That's okay. 10 Whole Foods. We want a train and test directory in here. OS. Okay, now we want to move the train files into the train directory and the test files into the test directory. We can copy that. Python, how to copy? It's shutil, right? How to copy file. Shut util. We want copy too. Jazrael is amazing. We want copy too. Import shutil. From shutil, import copy to copy. Train files. Traindir equals oh, we need a way to get their target class. File paths. No, this is a hobby project. But I'm going to, we'll see where it goes. So, yeah. Hobby project for now, but I'm still taking it seriously. I actually want to build this. Let's copy the files across. Train files. We need to get the back end of this. Okay. What can we get from this? What does glob do? Who knows what glob does? Glob. Dot split. Where did I just have that? Real Python pathlib. Can I get different paths of the file? Home. I need to break it down. path.parent.parent. Beautiful. Parent.stem. No, I'm just copying the files across. I'm copying the files from these directories into train and test directories. Trained. So for file path in list train files, file path beautiful. Okay, there we go. Okay, so for file path, class equals then copy target file to target dir. And then we want everybody sing trainer print path lib.path trainer tag class. Yes, yes, yes. So this is where we want to copy it to. Oh. Friends, let's do it. So copy to source is the file path. And the destination is No such directory, hey? Ah, I need to make the folders in there. Okay, that's all right. No, we don't want to do that. Because that's going to create a new directory every single time. Class list. Apple, 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 apple. Then we turn it back into a list. Apple, 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 apple. Apple, 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 apple. Apple, 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 apple. For does destination in copy 2 But what if I don't want to make a train and test set? What if I want to randomize it every time, man? Make doors. So this should see us. Now we should get some files in here. There we go. And we should have the same in here. Wonderful. Now we can get rid of this. So 4. Okay, this should work. Let's see. Oh, that's a function. Path lib. Hey, yeah, we're on. Okay, now we do the same for test. Now we're done here too. Okay. So now we can train a model with a training and test set. Ten Whole Foods train. And then we can go 10 Whole Foods test. And then we can add noise. We turn on all the data augmentations. And we run. Training a model, people. Look at that. Core ML model about to come through. Extracting the features. And now we can do the same with TensorFlow. Oh, it was raining here a little bit. So this is going to thank you, little math boy. I appreciate that. Said this is pretty cool to see someone do everything by hand. We're going to do, look, this is what most of machine learning is actually. Like you can download data sets from tutorials, but what happens when you don't have a data set that fits your problem? So that's what we're doing. We're spending a lot of time here just creating a data set. And of course we're starting small. We've only got 1,000 total images, but we're going to go from their environments. I don't even know what that is. But yeah, we're gonna build it up from here. So this is going to train a model. I'm going to go to the bathroom in a second, and I'm going to then, we're going to code a model. So we're going to see if we can beat Create ML is training a model for us on our training and test set. We're gonna build our own model from scratch in a second. That's what we'll do when I get back. All right. I'm back. So, oh, I had a drink. Wow, beautiful. So you're right. These are very accurate. And Daniel sings. I'm going to have a. You know what? I need to have a little moment where we just sing. I'm going to make a song for my PyTorch course, which is called the PyTorch Optimization Loop Song. So, look at that. That's a pretty darn good model to start with. You can't get much better than that. Of course you can. Like chicken wings, you can get better. Blueberries, you can get better. But you can't get much better than that. That's almost 100% across the board. Testing 94%. We'd want to push that to over 95. But let's go. Let's replicate. Let's see if we can beat this. Let's see if we can beat this using TensorFlow. I don't know what model Apple uses behind the scenes, but let's get a preview. Let's see if we can get a random image from maybe my photos. Let's see if we can beat this, hey? Together we can. Do we have a photo of apples here? Mango. Chicken wings, right? There's a great photo of chicken wings. Some delicious wings. Can we do this in the model? Chicken wings. This is not in the training set. Hey, what's happening here? Buddy? Add files. That's all we want to do, is we just want to build a model that can identify chicken wings. Hey. All right? Did that get it from the file name? I don't know. Maybe it did, maybe it didn't. Does it really matter? Doesn't matter. Let's now get another one. Let's get some beef on there. Do we have a photo of apples here? Because remember, our model can only really identify what it's been trained on. Egg? Let's put up some egg. Oh, and some steak. There we go. Look at that. We've now built a multi-class model. We have egg and beef at the same time. Miracle. See, this is where the things are going to start to unfold here. We don't have... It's going to predict something for the prawns, but it's not going to know what it is. Look at that. We have a whole different bunch of confidences here. Now, what can we do with this? Well, we could say, hey, our model's pretty uncertain on this because it's got 1, 2, 3, 4, 5, 6, 7 different classes. All right, too many options there. Can we take a photo? Use your iPhone's camera to take a photo. No way. Can we do this? Have I ever got mad at coding? Yes. And I enjoy it. You got to have that up and down, you know. Sometimes things got to work and sometimes things don't work. If everything always worked, then it would end up being no fun, you know. We need some sample images. I had some on the desktop, didn't I? Nutrify, data. I didn't. I don't know where I saved all these images. My directories are all a bunch of hoobity-doobity at the moment. I swear to God I was starting to export some foods. Sample food images. I was really starting to export some foods and then it's made a liar out of me. But that's all right. We'll move on together. I have a lot of crap here. Let's see if I can get my iPhone and take a photo of something and it identifies it as something. Who's ready for a real world test? We have a carrot here, and we have bananas, and we have blueberries. Okay? So let's see how we can do this with the iPhone camera. All right, ladies and gentlemen, we have the real world test. I've got an iPhone here, and I'm going to... Let me adjust this camera so you can see. This is Nutrify, the first model coming to life. Very big moment. Very glad we have this on the stream for document purposes. Food is here. You can all see the food. My face doesn't really matter. We're building technology here. Okay. Let's see what happens if I take a photo. Use your iPhone's camera. Oh, magic. My camera just opened. Take a photo with Daniel's iPhone. Let's try the blueberries first. Who's ready to see what happens? Photo. Use photo. Blueberries. Oh. We did it. We did it. The real life test worked. Who's ready for another test? Let's see the bananas. I'm going to sit right down in here like this. Take photo. All right, we've got bananas. We've got a little bit. Let's make it a little bit harder, hey? We'll put the blueberries in this side. I'll show you the photo in a second. Well, you're going to see it up there, aren't you? We've got this photo. Has a little bit of carrot and a little bit of blueberries in it. We're going to use it, the real life test. Oh, look at that, friends. Hello. Yeah, banana. Now look at that. Predicted a little bit of banana, well, mostly banana, which is right. Blueberries and apple. Now let's do the final test, which is a carrot. The real life test. Take a photo with Daniel's iPhone. Now let's do just the carrot. All right, we've got a photo of a carrot. It's getting uploaded. Boom. Yeah. Now we have a problem though. What if we were to do something that isn't food? Like if I just take a photo of this mouse, right? Upload that photo. Yeah, see, that's our problem. We'll fix that later on. But we need to add a class. I'm getting hungry looking at all these pictures of food. That worked far better than what I thought it would do. Let's bring me back up here. Let's see what we can do writing a model with TensorFlow. But that is the live demo, the first live demo of Nutrify. That's actually amazing. I'm really stoked with that. And Lil Math Boy raises a fantastic point. What if my mouse is 46% honey? Fantastic point, Lil Math Boy. Would you say that this mouse is 20% chicken wings? I'm going to take a photo of this. But have a look at that. Carrots. We've trained our first model. First model is doing very well for chicken wings. Look, these are with images downloaded from the internet. Holla at your boy. And there's some blueberries in there. Why don't you take a bite of your mouse and see? Hey, I'm not falling for that. Okay, let's go to Colab and let's start writing some computer vision code to new notebook. Hey, I want a new notebook, Colab, to do the same thing that we just did, but with TensorFlow. You're right, it might have a similar nutrient composition. My mouse, I did purchase the nutritious mouse. So food vision 00 food vision 10 model test, a 10 food model test. We need a way to get our data set to Colab. Import TensorFlow. What version is TensorFlow up to now? 2.6.1? I reckon the Create ML models are pretty darn good. Like, so we got 94% testing accuracy. Let's see what we can do. 2.6, okay. So Colab's running 2.6. Can we get a GPU, please, Google? Well, thank you. Friends, I am ecstatic at how well this worked. The first ever prediction. The mouse is 46% honey. What GPU do we get? NVIDIA, please give me some stack of GPUs. I'm training a model on only 800 images at the moment, but I'm going to be training a model on close to 1 million images in the coming months. We got a Tesla K80, which is like a 2014 GPU, but it's free. Okay, now, how do we build a computer vision model? Let's go to my book. See, this is why I wrote a book, so that the code is just easy referenceable. Transfer learning. Let's go fine tuning. Do we want TF Keras applications? Here we go. Base model, yada, yada, yada. Have a look at that. We don't want ResNet. Let's get an efficient net B4. But first we have to load the data. I'm telling you people, modeling is The fun part. Okay, we need to upload our data. How big is this if we zip it up? .4 gigs. That might be an issue uploading it to Colab. Wonder how quickly we can get this to a Google storage bucket. GS util. I think we should be able to clear CD Nutrify, or is that in code? LS. We're zipping this up. So I want to see if I can upload this to Colab. It shouldn't take too long. I mean, sorry, Google Storage. Let's go to console. Friends, we're nearly completed one lap of the data flywheel. That's something we need to do. Let's write this down. Nutrify. We need to next is create a class of not food objects that the model understands what's food and what's not. Boom. Okay. So food vision. Do we have a bucket? We have a bucket. Cloud storage, food vision images. But that's a whole bunch of different images. They're solo images. Now, create bucket. Let's call this food vision test. No. What can we call this? Food vision image playground. We'll upload it to the playground. We'll create it in the US. We'll call it standard, uniform. Create. Okay, food vision image playground. Now, I think if we go back to terminal, do we have the zip? Ten Whole Foods zip. We want food vision playground. Food vision image playground. So let's go GS util, copy 10 Whole Foods .zip, and then we're going to upload it to food vision image, food vision image playground. What is GS util? Yeah, CP. I thought it was copy. Oh, 10 Whole Foods. Oh, GS. I need to authorize classic. Okay, I'm going to make sure that this is off the screen. Okay, it's just me here. Hello, everyone. I need to authorize my Google Cloud login. Samantha, welcome back. Now I can go. Okay, we're back. So we're uploading files to Google Storage so they're easily accessible. I think this will be faster than uploading them straight to Colab. Samantha, look at this. We have the first real test of our model in the wild. Identified chicken wings with 100% confidence. Identified steak and eggs. We have prawns. It's not trained on prawns, so it doesn't know what they are. So we have beef, egg, carrots, apples, strawberries, chicken wings, honey. We have blueberries, banana, blueberries. There we go. Banana, it got that one. Carrot, got that one. Honey. It announced, it looked at the mouse as honey. Story time yet. The question was, what was my best story as a Apple genius? There was one time we went to a training seminar in Sydney, and Apple was paying for like the entire thing for 3 weeks in Sydney. It was like you stay at this very fancy. I was based in Brisbane, and you stay at this very fancy hotel with black marble and stuff like that. And then you would go to training, which was at the Sydney HQ, to learn to be a genius. I think they've stopped this now. You do training like online, which is a lot cheaper. Oh no, it's lagging. And so we went down there, and the way we sort of worked the system was that if I said that I went to the doctor and got a medical certificate saying that I was snoring, so I got my own room, which was a sick idea. I got my own room, and the funny thing was everyone did the same thing. And of course, being a large company, you don't question medical certificates. And who's going to question a medical certificate that says you snore and that you need your own room? So I had my own room in this dope hotel, and then I went down, like every day I gained like 5 kilos over 3 weeks because they put on a free buffet every morning, and the buffet was just like world class, and it was all being paid for. And so we go to training. Then there was one night where my godfather, who's a wild animal, lives in Sydney, and we're telling a story, by the way, while this is uploading to Google Storage, and he invited me out, and at the time I wasn't drinking at all. I hadn't drunk in like 6 months because I was training. I did a bodybuilding competition, and I was staying really fit and whatnot, not drinking, just eating really clean. And I was pretty lightweight, like I was ripped and shredded. And I go to this dinner, and I get there. I think we're going to dinner, actually. So I'm excited for training. We're going to go to dinner. I'm going to see my godfather. I haven't seen him in years. I know he's a bit of a party animal, but that's all right. We're just going to have dinner, and then I'm going to go back to the hotel and chill out, go to gym or something. And I get there, and I hadn't eaten all day, and the first thing I see is 2 beers on the table. And so, it turned into an absolute wild night. I can't remember hardly any of it. I was in a town that I'd never really been in. And we just went all around exploring Sydney, these underground bars. Again, I can't really tell you much from it because I don't remember the night. And I do remember getting home vaguely, not actually getting home, but being home vaguely, just being in the bathroom, vomiting and probably excreting bodily fluids from every orifice in the bath, and then just like flopping around like a crazed wild animal like a hippopotamus in a mud pit. And then the next thing I know, I'm getting woken up by a knock on the door, and it's my training partners that are saying, "Hey, we've got training in 10 minutes. Are you coming?" Because usually we'd meet up in the morning and go to breakfast together. And I'm like, get out of bed. Obviously, I'm hungover as fuck, and like just in a bad way. And I'm like, yep, I'll be there. Oh, I just slept in. And so when I get up, I remembered what happened in the bathroom the night before, which was not pretty. Absolutely not pretty. I didn't even bother checking it. And so I get out of bed. I don't even look at the bathroom. I just get dressed because the cleaners are going to come to the apartment at like 9:30, 10. I just get dressed and I leave the room and I go to training. And we're at training and I'm feeling bad. And we're trying to repair these computers. And so I'm trying to learn how to be an Apple Store genius technician and repairing these computers that are like $10,000, like the state of the art. The new Mac Pro, when it was like that trash can, and you're trying to replace these components. And imagine trying to do that like just hungover as balls. And I'm just getting nowhere. And so I'm like, well, I'm going to take the rest of the day off. So I tell the dude who's running the training, very nice guy, I'm feeling sick. I'm going home. Good timing because everyone was sort of going to get lunch or some food or whatever. And I go meet the boys, get some food. And I'm like, I need a Happy Meal. And so I hadn't eaten McDonald's in like a year or 6 months or 2 years, maybe longer. I don't know. And I ate a Happy Meal. And the guys knew how hungover I was. And so on the way back to the apartment, I get a call from the hotel saying, "Hey, is this Daniel Burke?" And I'm like, yeah, it is. And they're like, "Hey, we want to let you know that we had to hire external cleaners to clean the apartment. Whatever happened in there last night, like our regular cleaners weren't able to clean it, so we hired a team to come in and clean it." And so whatever I'd done in the bathroom, again, I have vague memories of this, but I do remember causing an absolute mess, vomit, probably everything else, and didn't look at it after. A team has had to come in to clean it up, and they're like, "Well, it cost us $400. Do you want us to charge that to Apple, or do you want us to charge that to you?" And I'm like, "I'll come and pay that bill now." And so went, paid the bill. No one is any the wiser. And so that's the fun, wild times of being a genius, is that you're working for a large company who have a lot of money and that can pay for a lot of things, except for cleaning your hotel bathroom when you've trashed it because you're a drunken idiot. So that's one of the fun stories of being an Apple genius. The rest, of course, are great. We used to get pumped at the store. Like it was a really fun place to work with young people, but just you can imagine how many people go to the Apple Store, right? So it's like you're just always under the pump. So you're always like cooked. You talk to 100 people a day, and so by the end of the day, no one knows what their name is or like where they live or anything. So like a few times after work, like I just sleep on the street till my next shift. And then people would come in. No, I'm joking. I wouldn't do that. Then people would come in. So the phone repair room was a room that was like half the size of this. And people would come in, they'd drop their iPhone off, they'd smash their screen or something like that. And the phone repair room was like like not even as big as this room, like literally probably like the size of two of these desks. And you would just get iPhones lining up. And so it's a very stressful environment. You have like 20 iPhones at a time to repair, and you still have to repair them by hand, like you're unscrewing the screws and ejecting them and putting the screens on and whatnot, and then calibrating the screens. And you're limited by the amount of time the screen takes to calibrate, because it's a very, like, when I just said what I just said, it's actually a very good process that they have in place, as you could imagine Apple do. And so all of the bad stuff typically was with the people that were, it's not the process, it was the people doing the process. And so when things would get hectic, like, it would just be fun to see who could remain the calmest. And typically that was me. And so you'd get like other staff members that are just like losing their minds, and I'd be in the phone repair room just listening to like Zen music. And they'd come in and they'd be like, "Is Dan listening to Zen music?" And they'd be like, "Yeah." They're like, "Has he lost the plot?" And they'd be like, "Yeah." And I would be like, "Yeah, I have, but that's right, you hold it down." And so the phone repair room was just a boiler room of just repairing phones and whatnot. But I really liked talking to people, because I used to be the guy. By the way, we're still waiting for this to upload. Once this is uploaded, we've got 300 megabytes worth of story time to go. And then we'll build a TensorFlow model. But I used to love meeting people. My favorite types of customers were the ones that come in very hot-headed. And so what I learned is that it's very hard for someone to be, like, of course, people, this is what you got to realize about everyone. This is the beauty of working in a customer service role, is that you meet hundreds of people, and you meet people from all different walks of life, and you got to realize that everyone's life is as deep and as meaningful as your own. There's a beautiful word for it called sonder, and spelt like wonder with an S, so S-O-N-D-E-R. So you don't know what's going on in their life. Why are they coming in? Like, on face value, they're coming in, they're pissed because their iPhone doesn't last a whole day because they've spent 6 hours on Facebook, and they don't want to hear that they've spent 6 hours on Facebook. So you don't just go, "Hey, look at this app usage. It says that you've been scrolling Instagram for 4 hours. Why do you think your battery's dying on 4G?" So they don't want to hear that, right? People got other things. So I used to love being the one who would go in. Someone's come in, they're full of steam. This is what you realize. People mimic other people. So there's a value in, this is what people say, you're the average of the 5 people you spend the most time around. You see this very clearly in a customer service environment, especially one as busy as an Apple store. You got hundreds of people coming in an hour, and they're charged. Well, their phone's not charged, but they're just energetically charged. They just want to vent to someone. And you will be very surprised at how much someone will tell you if you just sit there and listen. And also, it's very hard. This is what I was getting to. It's very hard for someone to be angry at someone who's not angry at them. So if you remain calm and collected in that sort of environment, chances are they will become calm and collected and say, "Hey, I'm here to help you out. Like, whatever is going on, like, let's figure this out together." That was some great wording that you could use, is just like, let's figure this out together. The word "let's" is very powerful, because it's saying, "Hey, I'm with you in this." Not "I'm going to figure this out." It's let's figure this out. Let's figure this out together. Not just me, the nerd in an Apple shirt. I want to figure this out with you. So that were my favorite type of customers. People that would come in and they would be just angry. Some phone carrier has pissed them off. They go, "I just want to go rip into some Apple store employee." And they'd come in, then they'd find me, and they'd be like, "Hey, dude, what's going on?" Be like my happy, energetic self. And then they calm down sporadically. Look, there were some dickheads that just wouldn't, because that's just who they are, and that's life. Life needs some of them. The good people wouldn't be as good if you didn't have dickheads. So that was typically my role, is that if someone was coming in hot-headed, I'd be like "Hey, let's send in Dan. Let's send in Dan," and I'd come over super chilled. It's very hard to be angry at super chilled Dan, because I don't really get that angry. Because look, what is worth getting angry over, apart from the fact that, like, Facebook changed its name to Meta, which is baloney. But look at that. We've uploaded 1.3 gigabytes, so that's story time. My favourite story of being a genius is the time I got really drunk and vomited all through the hotel and had to pay a $400 cleaning bill while I was at Apple training. Then, of course, being in the phone repair room playing Z music while figuratively, the house is burning down and just chilling out. And then, of course, talking to hundreds of different people a day. Well, not a day, but a week and a month and whatever. I think by the end of the time I spent there, I'd had appointments with over 5,000 different people. And I had a customer approval rating of 88%. NPS, if you ever heard of NPS score. I was like the number one in the whole region. So, boom. Perfect time. That's story time. That's my genius story. There's plenty more, but they'll come up when they need to. So let's see if we've got some data here. Please tell me I uploaded it to the right bucket. Yes, I did. Ladies and gentlemen, we have some data on Google Cloud. Let's do it. Edit permissions. Hey, why can't I get permissions? Cannot get legacy ACL for an object when uniform bucket. Hold on, man. I want to make this public. Oh, classic. Oh, did my stream die out while I was telling that story? Wow, I just spent like 10 minutes telling a story and my stream was dead. How dead? Did you hear the part where I was getting really drunk and destroyed a hotel bathroom? Why can't I edit permissions? Cannot get legacy ACL. Oh, the drunk part of the story got deleted. That's all right. Hey, well, you're just going to have to watch the replay on the archive because I can't tell it again. Can only be told once every so often. Far out, Google Storage. You've made this bunch of... I just want to edit the permissions. Hey, what happened? There we go. Let's read the docs that it's telling us to read. Uniform bucket level access was known as bucket policy only during beta. Look, if it gets clipped, it's like, well, whatever. People, like, you watch the whole video. There's context for it. I was at a training thing. I got drunk. Destroyed the bathroom. Paid for someone to clean it. Everyone's got those drunk when you shouldn't be drunk stories. But you learn from them. Man, Google's docs are probably some of the worst. Cloud storage offers. Access control list. Man, I just want to build a machine learning model. I need to switch to fine grain access. I do want this public to the internet, that's fine. shouldn't do that. If I make it public to the internet by all users, that will... What happened here? Let's see what this says. Go back. Let's just Google this error. Look, these buckets... If I change projects to TensorFlow course, then I have a storage bucket here. I get permissions here. So what's the difference? Okay, I want fine grain control. There we go. We can download images now. And we'll unzip them. Should have done that quietly. Of course it uploads a file called macOS. Okay, now let's load in the data. Oh, we're getting a bit of mood lighting here. Mood lighting, baby. Hey, it's your boy, Daniel Burke here. We're talking some late night DJ coding action. We're going to build a TensorFlow model to identify what's in different images of food. There'll be food images of chicken wings, carrots, bananas, blueberries. Hell, there'll even be some images of mushrooms. You with me? Well, let's do it together. Did this get changed from TF-Kera's pre-processing? Let's see. ImageNet B4 is 380. EfficientNet B4. ML Community Day is November 9. What is TensorFlow ML Community Day? Hey. Here we go. We want vision. We want Image classification. We'll do TensorFlow Lite as well. We'll see if we can first beat it with EfficientNet. Wonder if this still works. My gosh, this field's bright. Black Tomcat, what's happening? We are building a computer vision model for some food images that we've downloaded from Microsoft Azure. Then we want trained. What batch sizes do we want? Obviously 32. Hey, man. Oh yes, we downloaded the images from Microsoft Bing using a little script, some program that I wrote up here. Data download. But the project that we're working on is called Nutrify. The objective of Nutrify is to take a photo of food and learn about it. And we've got a machine learning model that worked here before. Didn't do very well on my mouse. It thinks it's made of honey, but that's okay. Predicted this one as carrot, this one as banana, blueberries, beef. We've got egg and beef there, that's correct. Eggs there, beef. And then chicken wings. And yeah, the data that it's trained on is downloaded from Microsoft Bing. How do I test this out without getting hungry? You're right, I actually got hungry before. All of my testing images, testing foods, just here. They were down on the floor before. Let's get some light. There we go, nighttime stream. We're on here. What do we got? Friday, 6 p.m. Okay, so we've got about 900 images total. And we should have a TensorFlow data set. Yeah, a batch data set. Let's get rid of a bunch of these. And we'll look up TensorFlow data best practices. Nighttime stream at 10 a.m. Hey, so we're from different places. So the performances should be in the summary down here. Best practice summary. Now we don't have any image augmentation here, but that's okay. Prefetch TF. Yeah, that's the main one we have to do here. Okay, we've prefetched them. Is that? Oops. Okay, who's ready to fit a model with TensorFlow? Just had to edit this code a bit. So we're going to train for 25 epochs. We are using EfficientNet B4. Oh no. We're going to download the model. Epoch 1. Going to move all the data to the GPU. A whole bunch of calls down here. And then we're going to get out of some extra tabs, hey? See how long this takes. We can do the same thing with TensorFlow Lite in a second too. There we go, people, we're on. How small does the model become? So it uses EfficientNet Lite as the first model for what's an epoch? So an epoch is a lap of the data. So if we have about 800 total images, one epoch means that the model has gone over every image in the training data set. So an epoch would be, hey model, look at 654 images and try and learn the patterns on those images. And we have 1 out of 25 epochs because we set epochs to there. 25. Yeah, the accuracy is doing very well on here. So in Create ML, we had 94.7 validation accuracy. So we have 95% validation, 94 testing. Rish, here we are training the model. We're not training the data. The data's staying the same. We're training the model here. I think we should put in some data augmentation here. I wonder how training happens in Create ML, because that was really good. Okay, so we're getting pretty close to the same results here. About 94% validation accuracy. So this is very exciting, people. I'm going to save this model actually. The model from this is only 148 kilobytes. Can I send this in a text message? Haha. Image. I can't change the description. So the validation accuracy has gone down here. We should put in some data augmentation. Want to become famous? Buy followers on bigfollows.com. No, thank you. Oh, you can use random augment. Okay, so the accuracy is going up and down here. We probably should have put on some augmentation. There was a paper that I found the other day that was about data augmentation. There's a super simple way to do it. That's what it was. Trivial augment. So we get about 94% accuracy here as well. Automatic augmentation methods have recently become a crucial pillar for strong model performance in vision tasks. Trivial augment's effectiveness is very unexpected to us, and we perform very thorough experiments to study its performance. So how did it perform? Outperformed random augment. Beautiful. Okay. I'm going to look into that later on. So I think we've done enough for this stream. We've accomplished what we wanted to accomplish. Of course, we can clean up some whatever we got to clean up. But we built a small scale machine learning model to fit on the data. And we tested it on real life images. Oh, let's update the Nutrify homepage. Nutrify's goal is to enable you to take a photo of what you're eating, about to eat, or food you see. That could mean calories, nutrients, where the food comes from, what it goes with, how long it's been around for, where it's native, etc. To start, keeping it simple. Whole foods only. For example, an onion or a banana rather than a dish like chicken curry. Building the vision models or likely take a fair amount of images of food currently being sourced. But if you'd like to help, you can upload an image of food. Thank you, Siobhan. I appreciate that. And before we end the stream, of course, we are committing our code to GitHub. Yeah, so the model that we built, got 97. So if in doubt, keep training. Yeah, now it's starting to overfit. So there we go. We trained a model. We downloaded images from the internet. We've tested it on real images. We've tested it on images you would probably take. Look at this. Beautiful. So that's what we've done this stream. Predictions, class label probs. I'm going to share this with my brother, who's currently coding the iOS version of the app. In another stream, we're going to use our model, whatever model that we get. We'll integrate our model into a web application. So Nutrify.app should be uploaded as well. Updated, my bad. Sweet. Now that has got to be one of the best looking homepages for a product I've ever seen. Hey, we get 97% accuracy here. Pretty darn good. Okay, actually, I'm going to link my archive channel here as well. Twitch. Am I going to see my own face here? Yo, 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 stream meta, yo. Stream meta. Am I going to see my own face here? Yo, yo, yo. Hey, this is saying I've only been live for an hour. I must have gone off. The YouTube playlist is here. I'm going to upload that to the... Well, it says what it needs to say. Sweet. How's the model going? Yeah, it looks like it's maxing out at 96.88. And it's going to go about the full epochs. Okay, it's definitely overfitting now. Wow, it just converged even further. So we're getting basically 100% accuracy here. Efficient Net B4. Holler at your boy. So Nutrify.app should work now, people. Wow, we can't finish this stream without finishing this. I'm gonna go to the bathroom quickly. We have a model that is performing at basically 100% accuracy. Well, the highest is this. Is it going to save it to the best performing? We'll let this finish off. Let's upload an image, shall we? Do I have an image on GitHub? I need some sample images up here. There we go. We got some sample images in the house. What are we finishing up with here? About 100% accuracy. That's delicious. Kenyan yum chom, grilled goat. Oh, delicious. How big is this sample images file? 100 meg. No wonder GitHub's struggling. Okay, we get about 94% accuracy on the test data set. 94.5, which is very close to what we got. Still not uploaded. Nearly done. Night, Siobhan. Thank you for tuning in, brother. I appreciate it. Sample food images. Yes, this is what we want. Need to test our model on a custom image. What do we get wrong here? We need to resize. TensorFlow. Moment of truth, people. Chicken wings. Look at that. Boom. There we go. Okay. We've got a way. We've got a way. We can train our model. We've got a way to download data. We've got a way to map our, or figure out the nutrition information for this beautiful, delicious food, chicken wings. Let's continue on in the next stream. If we reload this, don't forget, check out Nutrify.app for updates. That'll link you to the GitHub. It'll also link you to Twitch and the replays on YouTube, which will be live after we keep building. But thank you for tuning in. I will see you next time. Let's just go back to our VS Code and tick this off. We go there, tick. So next I'm going to clean up all of the code in here so that it's manageable, and then really refine the model building process, model deployment process as well. And that way we can start to build an app which is similar to this one, but enables us to upload an image of food and then have our model predict on it. Actually, that's what I need to do, is add, let me write that down here. Add a class of no food so the model can recognize what's food and what's not. That's what I need to do. Clear. And clean up code repo so it's easier to understand and manage. But that is all. We did a huge stream today, a few hours. Thank you all for tuning in. We cleaned up the images that were broken from our file structure. We cleaned up the metadata. We built a small machine learning model to fit the data, and we tested it on custom images. Look at this. Preview. Didn't work on the mouse. That's all right. We're going to upload an image. Make a class that's not food. Carrots, nailed it. Banana, nailed it. Blueberries. Didn't know about prawns because, well, it's not in the training set. Steak, it got a little confused here, but that's all right. That's what we want. We actually want that. Egg and beef. We want to find out where our model's predicting two different things, because that'll help us with image labeling in the future. And then of course it smashes the chicken wings, and we've got the replicated code here in TensorFlow too. Chicken wings. Okay. We have image to ingredients. Ah, yes, I have seen this one. So Food 101, where's the data set? I'm going to read this. Thank you so much. Copy that, save. Save that to ML and Nutrify. Okay. Thank you all so much for tuning in. Don't forget, you can see nutrify.app for the homepage, and I will see you all in the next stream. Peace.